Welcome back to Rishabh's Engineering. Our question is counting bits. Question is saying given an integer n, we have to return array of length n plus 1 such that for each I range is given from 0 to n, and for that I as an index in this answer array is the number of ones in the binary representation of I. So n is given to us. Let's say if my n is equal to 5, and I have to return an array answer of length n plus 1. For this case n is equal to 5, we have length of our array 6, and it is saying for any I as an index in this answer array is the number of ones in the binary representation of that I. So let's say for 0 we have binary representation as 0, and there is no one present in this array, in this binary, so our answer is 0 for 0. For 1 our binary is 1, and if you count number of ones we have 1. For 2 we have 1, only 1 present in this in this binary, and for this 3 we have 2 times 1s in this binary representation, answer is 2. For 4 we have 1. For 5 we have 2 times 1, and at the end you have to return this array. So this is the question is saying. And if you guys are thinking of brute force way for doing this question, let's say let's take any I index. Suppose if my I is equal to 5 and its binary is 101. Can I say if there is 1 in the end, my corresponding number is odd, or how to check that? I can take modulus of 2 and I can check there is 1 in the end or not. If there is 1 in the end, please count, and in the next iteration we have to take next numbers like 1 and 0, and we can check for 0 also, and in this way you can check for all the numbers. And I am doing it only for I is equal to 5, and we can do it for all the n's and store corresponding number of counts in this array. Let's talk about time complexity here. Suppose if my I is equal to 15, can I write it in the form of like 2 raised to power 4 minus 1, and 4 represent my maximum length of the binary. This is my maximum binary length, or I can say it is somewhere like 2 raised to power something. I can say it is nothing but log of base 2 of this I, and I'm calculating for this all the n values, so multiply it by n times. This is my time complexity. And space complexity is big of 1 because I am not using any auxiliary space here. So you guys can try this approach. I'm directly going for optimal one. Let's take an example of n is equal to 10 and write its binary representation. So can you guys think of an approach where we can use previous calculated indices to calculate new array indices? Let's say for this 0, I have my count of 1 as 0. For this one I have 1, and to calculate for this 2, can I say I have same pattern repeated in my next length for 2, like you can see here, you can check this, this is the pattern, and this pattern is same here, but I have only extra one here. Or I can say, if my I is the power of 2, because whenever my I becomes the power of 2, um, uh, my length becomes the previous length plus 1. Like for in this case I have binary length of 1, and in this case I have 2, and when it becomes when my I power is 2. So, or I can say, if my I is 2, please use previous calculated indices from 0 and add plus 1, and I have same count as present in this 2. For this 3, I can use the next count, my 1, and if I add plus 1, I get answer 2. And again, if my I is the power of 2, can I say my pattern is again repeating from 0 to I minus 1. You can check this pattern, 0 1 is repeating here, and 1 0 again, double 1 here. This pattern is repeating, and we have to add plus 1 for previous calculated indices. Or I can say, please use again my counts from 0 till I minus 1. For this I is equal to 4, I can use this 0 count, and I have to add plus 1. Answer is 1. For this 5 I can use 1, and my answer is 2. And in this way we can calculate from 4 to 7. And when again my I is becomes the power of 2, start calculating from 0 and add plus 1. So in this way I can do. So let's try to write this write code for this approach. Let's take an answer array of length n plus 1, and for my 0 I do not have any count. For 1 I have 1's count as 1, and I have to run this loop from I is equal to 2 till the n, and take, and I have to take two variables. I have to take let's say j to start calculating from 0, like I have to take j, and I can take here I as 8, or whenever I am going downward I have to increment I plus plus and j plus plus, and I have to add plus 1 in this array of j index. And again, if my I becomes the power of 2, again I have to assign my j as 0, and I can trace my next power of I in this variable, next power. Let's say my j is 0 and my next power is 2. If my I is next power, please assign my j as 0, and my next power I have to multiply it by 2, and for corresponding I index I have to add array index at j plus 1 and increment this j, and at the end I have to return this answer array. And I have to write one base case. If my n is equal to 0, please return this array. There's one mistake. And yes, this approach is accepted. Yes. And if you guys talk for time complexity, so time complexity will be big of n, because I'm using only one for loop, and I'm using j just for taking previous counts. So my space complexity will be big of 1, because I'm not using any auxiliary space here. If you guys find this video helpful, please like and subscribe. Thank you.